Hello, everybody. This is the first episode of the Beyond Automation live stream podcast. I am here with Suresh Mathew, founder and CEO of Sedai, and we're also joined by a special guest who we'll be introducing shortly, Ilan Rabinovitch, who's the Senior Vice President of Product at Datadog. The goal of this series is to help SREs, DevOps, and those who are managing operations to really uncover new solutions to the problem of running modern applications. The title, Beyond Automation, expresses a need to go beyond today's approaches, which have served us well to this point, but they're beginning really to fall short, given the challenges that are posed by new architectures, rapid release cycles, and the need to do more with less, which we're going to dig into today. Today, we're going to be looking at some of the challenges that are coming up around application performance, reliability, and cost. Given the rise of containers, serverless, which are creating new challenges. We'll look into the strengths and limits of the observability paradigm, and also how autonomous solutions have emerged, which are really some ways that can solve the challenges that are being posed by modern apps. So over to you, Suresh.
Hey, thanks, John. Good morning, good evening, good afternoon, everyone. I'd like to welcome Ilan Rabinovitch, SVP Product and Community at Datadog. Those of you who do not know him, we have a dozen of customers from Datadog. I talked to one about Ilan. So what he said is he asked for a feature from Ilan, and the feature was ready in a month. So that's Ilan. Welcome, Ilan. It's an honor to have you here.
Sure. Nice, good to be on. Thanks for having me, Suresh and John. And I would say, I would hope. I don't want to set expectations that high on myself and what I'm working on, but yeah, always try to be responsive with partners and customers and the like. So yeah, excited to be here today and chat a little bit more about what we're seeing in the space.
Perfect. Thanks, Ilan. So, being a prominent figure in Linux communities and APM, so we see that there are three architectures majorly driving the conversion to microservices from services. We used to have like hundreds of services, but thousands in a startup itself is super common these days, right?
Yeah.
And we three main architectures really driving it: Kubernetes, serverless, and serverless containers. And these three are pretty close competitors. But in the next 3 to 4 years, who do you think will be leading this journey? Will there be one? And what in your mind would be the leader in this journey?
I don't think these are either or conversations. It really depends on what you're trying to accomplish and what your organization needs in terms of abstractions, in terms of compute requirements, in terms of economic requirements. And so, what I've seen, what I've seen is, in both in architectures that I've observed, as well as in talking to, talking to folks in the field, is it usually ends up being a combination of these different technologies that fit into your environment. Serverless is great for certain workloads. Containers are great for others. In the serverless container environments, it's oftentimes a mix of some of the benefits and drawbacks from either end. So I don't think it's going to be a situation where suddenly one architecture wins our industry over. We just have to figure out, you have to look at each technological and business problem as it's as they arise and decide what's best for organizations or for our products. And I know that's probably that's a bit more of a wishy-washy answer than you were looking for. But if you look at some of the container and serverless adoption reports that Datadog had put out over the last couple of years, like that's a trend that seems to to be proven in the data, which is organizations that are using serverless are very likely to be using containers. Organizations that are using containers are very likely to be using serverless. It's just these things go hand in hand, and they help complete the landscape of what you're trying to do in your organization.
All right. Thank you.
But serverless containers, I think, are have been super popular over the last couple of years. Like Fargate, Fargate really changed the way folks were thinking about compute, and only paying what they need, taking away a lot of the pain and toil of managing clusters. And similarly, that's led to some similar things that Google and Azure, right? Like Cloud Run is Google's answer to that, and that's seeing a ton of attention as well. Azure has their own services, so fairly popular. So,
Yep.
And yeah, so as we're showing in some of the slides here, this is a study that that Datadog did, does every year. And one of the things that we found out is just folks are looking to get away from having to manage that infrastructure, getting away from having to manage the compute, and instead are bringing, looking at abstractions, looking at platforms that take all of that effort away from them and let them focus on their business and their business logic, and and operating for their customers rather than operating on undifferentiated compute.
Yep.
Yeah, and I think here we're showing Ilan some of the other data from your survey as well, which is really about serverless adoption overall. Yeah,
for sure. Yeah, and I think that's another that's a trend as well, right? Which is we all, whether thinking back over the years to like whether it's Heroku or Elastic Beanstalk or other platform as a service technologies that let you upload your code and have it run. Experience we've all, engineers and engineering teams and product teams have wanted for years. Like, take away all the pain from me. Let me just focus on the business logic and the experience that I want my customers to have. And the main challenge over the years has just been the limitations that sometimes those platforms have. You might need to tweak a bit more, or there might to tweak something a bit more, have more access than something like a Fargate might give you for security reasons. And so you end up looking at other paths. And another often ends up being cost. And I think what you're seeing over the last couple of years is the cloud providers have done a very good job at eliminating most of those limitations, or reducing them at least. And then they've also found ways to make these platforms a lot more cost effective. So between the two, that's why you're seeing this just amazing adoption of these PaaS technologies, whether it's serverless or Fargate or Cloud Run or others that really help. That really help you focus again on your business problem rather than the platform problem. And so hopefully Datadog will put out some more stats this year. Over the next, usually they do them around KubeCon and other events, and so we'll get a chance to see what the 2022 numbers look like. So.
Yep. Yeah. What's your expectation for 2022 and beyond in terms of which of these kind of modern architectures that Suresh mentioned is going to gain share? Do you think it's going to be serverless containers, sort of serverless functions, gaining relative to Kubernetes, or where would you put on your?
I think we're just going to. My take is we're going to continue to see this trend of PaaS type services, whether it's serverless or managed containers, continuing to take adoption. And I think I hope you'll see. My expectation is you'd see similar things in other clouds, similar to what we've seen happening over the last 3, 4, 5 years in AWS, and that's just based on the maturity of the offerings getting better. The one loser is going to be, and I don't think anybody's losing, right? At the end of the day, these serverless things still have servers underneath them. But I think the main change will be you'll just continue to see a withdraw from self-managed compute, right? Where you have to manage the updates, the security, the availability of all these different resources that honestly, at the end of the day, you don't care about. Like you don't care if it's running on an EC2 instance or a Lambda or a Fargate container, or a Cloud Run, or any of those other things. You care, is your API available to your customers? You care, is the checkout process on your website available to your customers? Mm-hmm. And so we're seeing, that's what you should focus on, not how do I tweak a little bit more performance out of the kernel on my random Linux box in EC2. Like that's not the thing that moves the business. Now, there are specific workloads and, or certain workloads where that's not going to be possible. If you're running, I don't know, you have specific needs around types of compute or types of IO or, escalated privileges that you need elevated privileges that you need in those environments. Maybe you'll do something different, right? But I've seen everything from e-commerce sites to entire fitness sites. There was one. I remember seeing a talk at Dash a few years back by a company called OpenFit, where they had built their entire sort of workout as a subscription workout service. They built it entirely in serverless without a single piece of stateful compute. Like that's the new generation of things. But if you're doing hard compute, I don't know, maybe you need some of the GPU stuff, maybe you need some high IO, you need specific memory or CPU requirements that those PaaSes can't offer for some reason. well, EC2 and GCP and all of these other compute platforms are still available to you. But I think that's where you'll see the trend going, is where you can move things to managed, because you got better things to do with your time than reboot servers.
Yep, it makes a ton of sense. Yep. So I think it's just a default or takeaway, I think, for the audience here. I think, in terms of architecture-wise, I think we're going to see the modern architectures grow, and kind of the more managed it is, will gain share the fastest, I think. So thanks, Ilan. We wanted to cover another sort of related just trend that I think is impacting everybody in the industry now, which is really the need to just release faster. Elizabeth, if we could take a look at some of the data here. We've got a recent survey from GitLab here, which is basically suggesting that daily releases are pretty much becoming the norm now in terms of what DevOps teams have reported here. Ilan, wondering, what are you seeing in terms of sort of release velocity from where you sit, and how do you see it sort of impacting cloud ops teams?
This is a trend that we've been seeing going on for a decade, back to the start of the early days of DevOps culture discussions, and the early days of before that it was agile systems administration and other things, which is the more you deploy, and the smaller your deploys are, your releases are, the less risk there are that there's going to be an aberrant change or problematic change in them. This goes back to even the agile and conversations that we had as in our product development cycles, where it was let's put together small quick sprints in which we get something done, put it out the door, and then iterate on the next step. And so that trend's continuing. Depending, some industries you're in, like there's only so much. You even if you have all of these practices in place that help you get stuff out the door quickly, help you get out the door, painlessly. You still can only release, once a year, once a quarter, whatever your cycle might be. That often is the case when it comes to things like hardware, consumer software that folks actually install on devices in the field, right? Like you can't. How do you if you're deploying your software to a cruise ship that's disconnected and sitting in the middle of the ocean most of the time, you're not doing 20 releases a day. But for those of us that are working in the SaaS, in the SaaS space or the web space, there's opportunities to make these deploys happen quickly and painlessly over time, rather than doing them in these big, waterfall style big deployments. And so that continues to be the trend. I think everybody accepts that as as a best practice. Even if the main thing there is just be in a spot where deployment is easy and can be quick, even if you choose to not do it every day. Always be in a spot where you could be doing it every day, 10 times a day, a couple times an hour, whatever it might be, because that means that you're never being blocked by the technology or by the process. You're being blocked by your decision for your business on where you want to go. And so that's on the one hand, that means that we're all in a spot where we're building the tools or building the processes to let us move quickly. On the other hand, having things change all the time at that frequency, adds complexity in other areas. So that might be, whether around what's the state of production, what's running where, who deployed when, all of those types of questions. And that's where there's lots of, that's where I think a lot of the vendors in the space and the project in the space are starting to offer you things to help you understand that, whether it's things like service logs that help you understand who owns what, when they deployed it, what did they deploy, or automation tooling, like some of the stuff that that Sedai puts out, or observability tooling like Datadog and others put out. The goal with all of those is to help you orient yourself around this constant change, as we make change the norm rather than an aberration. So.
Yep. And I think we've got a question, Ilan, come from the audience here. It's a question around kind of the impact of serverless on DevOps or sysadmins. So I wonder if you could maybe contrast in terms of the ability to sort of release faster, and maybe the overall burden as you see it for sort of serverless versus maybe containers as a contrast.
Sure. I mean, one thing that never changes in this industry is we always have to learn new technologies, new technologies, new concepts, new paradigms for how we operate. And so if we go back 10, 15 years, systems administrators were, running physical hardware in different places and deploying that software, tuning that software. We didn't necessarily have DevOps at the time, but we had similarly smart folks trying to build automation around all of that. That was a whole different set of technologies that we were managing versus later on cloud and auto scaling and the dynamic environments that we had 5 years ago or 6 years ago. But the concepts were the same. It's the same. Still the same principles of how do you think about load, how do you think about scale, how do you think about performance and availability. We just had more abstractions between us as we started to move to virtualization or compute as a service. And I think that's a similar story with serverless or containers, which is we just have to move what part of the stack we're going very deep on, and start to think more. In many cases, we're starting to think more about the applications we're deploying for a business or the business services rather than the compute piece. But I assure you, there's just as much work for systems administrators and systems engineers and whatever other titles you want to give yourselves when you're managing a Kubernetes cluster, if not more work, than there was when we were running, bare metal hardware in data centers that got brought to us by Dell and HP and anybody else, that we brought them in. It's just the complex. I mean, the complexity has just moved around, and the type of tuning, the type of thinking that we have to do about things has changed. So, I'm not worried about systems administrators becoming the piano players of movie theaters from the 20s when all suddenly they were like, oh, they brought out sound in movies. We don't know what to do with all these people playing music in the background. No, we just have to learn how to play a new tune. Is all, and that's. I think that's going to be the case for a while. So,
yep, got it. All right. I know you mentioned sort of Kubernetes and the challenge of managing that. If we could, I think we have a sort of a prompt for some of the complexity there. Elizabeth, if we could pull up the slide around. Here we go. This is an interesting take that Hari Chandrasekhar from our team put together for a conference we did recently, where he took the example in an environment where you've now moved to microservices and you're needing to release quite fast. Here it's kind of once a week. What's basically the number of sort of knobs and dials that need to be tuned every month in order to get optimal performance? And basically, he gets to, in this scenario, kind of 36,000. So that's kind of a lot of configuration, I think, as the release cycles go up and applications get more complex. It looks like there's sort of a lot to do. So curious, Ilan, you must have a lot of customers at much bigger scale than this, kind of dealing with this. What's your kind of sense of how folks are kind of managing this?
I mean, I think this is why we've seen such a revolution in both management tooling, but as well as observability tooling over the last decade, as we progressed from cloud to serverless and containers and orchestrated containers and all they're like, is that level of complexity is boundless. You used to have maybe you used to deploy a server that maybe lasted 3-4 years, maybe it lasted the entirety of your time at an organization. Nowadays you have these functions and services that go away in seconds, and that change is normal. Hopefully you're hooking this up, as you start to do things to take advantage of the elasticity of the cloud or the flexibility of containers. You're starting to use some of the technologies like you mentioned, VPA and HPA, to make sure, to drive efficiency in your environments, or organizations are starting to. I think we've actually seen, lots of interest, lot of demand around it, but not everybody's yet, 100% tuned. As we move in that direction, connecting our observability data and our operational systems and our automation all in a loop there, so that you're, having things make decisions based on the state of production, based on the experiences your customers are having. Your automation makes a change based on that to try to, get you to a faster response time or a more cost-effective way of being deployed in production. And then you want the observability system to pick up that state again and say, things are faster, things are slower, tweak it again. Similar to how, I don't know, if you're flying a plane or driving a car, you're looking at the gauges on your car and you're like, I'm going too fast, I need to slow down. You put your foot off the pedal, you look at the knob again, you're like, got it, I've reached my goal. Similar, or a pilot. You pull the stick back, you're going up, you push it down, you're going down. Like, did your altimeter adjust with that? Hopefully all of that's hooked up together and you can make then, automated decisions, so that it's not a human sitting there staring at all these things all day. But yeah, we're seeing more and more of that automation. And again, that comes back to people just not wanting to do boring, tedious tasks all the time. Like the same reason. Why do we have auto scaling? Well, because when a little bit more load happens, you don't in the middle of the night and provision a server. Computers are very good at doing those standard tasks. Let them do it for you. HPA is a similar story in Kubernetes land, or VPA, or some of these other tech. Sedai I know can make a lot of this smarter as well. How do we make sure that the boring tasks that just have to happen all the time in order to keep your systems running at the levels that you want them to and at the cost effective nature that you want them to, that you don't have to have a human in the mix doing that. They can focus again back on things that provide business value. Like the same reasons we talked about using platforms and abstractions to get out of tedious administration work. We want to take advantage of the elasticity in those platforms and the automation abilities in those platforms, so you can get away from worrying about day-to-day operational work. This is where Suresh, just your whole background and how you've done this at a number of the very large, high scale environments where we look at the Googles and the Facebooks and the PayPals and others of the world, and we think they've got this all automated and figured out, and it's a blessing. And like they do have a lot of it figured out, but a lot of it is just this routine automation has been monitored. Process dies, something spins it back up. Container dies, Kubernetes spins it back up. You need more resources, great, you scale up a little bit, but it's not this is not it's not magic. Like there's tooling in place that has helped that makes this happen. So.
You had a question here about managed services and frequent releases. Does it sort of create availability issues for SREs?
Yeah. So, Ilan, I think this is where I think decision making is probably the key factor in this whole process, right? Be it availability, be it scaling, be it performance, be it cost. It's all about the decision. But once the decision is made, clicking those buttons and finishing it is another task. That's why generally, if you're automating, for example, let's say Kubernetes as an example, you have VPA and HPA, right? Now, who decides your application has to use either each HPA or VPA? That's one decision making. Second, now let's say I decide to use VPA. Now, how do I decide when to monitor, what to monitor, what is the threshold, when do I scale, how do I scale, how much do I scale, where do I stop? That's another set of decision making. So if you look at all these decision making, that's where I think people struggle. That's where autonomous systems typically come in and say, these decision making can be made a lot easier. Can you guys hear me?
Yes.
Yeah. Can be made a lot easier if you have an automated autonomous system looking at all the metrics, figuring out the dynamic rules and executing on it. That's what we did at PayPal. When PayPal had a massive growth or huge trajectory of growth, there were a lot of issues that we had to really look into. There were a lot of scale up and down that we had to do. And we said, you know what? When someone calls in for a scale down, the operators really call their VPs and ask, you know what? This developer is asking me to scale down in production. Do I have the permission to scale down? Because he's worried about scaling down and the service going down.
Yeah.
Right. And that should not be left to humans. Humans cannot do it. So it's just that someone has a job and someone is asked to click. So someone has to take the responsibility. That's all. That's why we said, you know what, let's develop an autonomous system and let that system take the decision.
Yeah. I guess just to, and I think the question was, was asked, like, do these things cause availability issues, moving to more frequent releases, moving to managed platforms? And I think the answer is no. If you do them, if you adopt them thoughtfully and methodically, and how you're, how you're going to do this, then and you've practiced this, then no. If you've automated your releases, you've automated your canary deployments and your dark code deploys and all of the other different tools that are in your tool chest for checking how a release is performing before it hits 100% of your customers, then if anything, it's going to be better. When there's one release that has one commit in it, you know exactly what that commit did. When there's a mega release that you spent the last 2 quarters building, you put it out there, there's hundreds of thousands, there's hundreds or thousands or more commits in there. What did they include? What's going to change? So I think more frequent releases does not. If you've got your story straight, and you know how you're deploying, you know how you're observing it, you know how you're automating it, it's not a bad thing. It's actually a very good thing for everybody. Now, if your deployment process is the same one that you used back in the day, where when you didn't have any of this automation, you didn't have any of this observability, you just upload some code, go get some coffee, come back, and hope your customers aren't having any outage, then yeah, this is going to be a miserable time for your SREs and your DevOps folks. And managed platforms, if anything, they take all this pain away from you. There's a bunch of SREs at Amazon and Google and Azure and every other cloud provider out there worrying about all of those availability aspects that you don't have to worry about anymore. You have to worry about, is your code working well? So I don't think this is a bad thing for systems administrators or SREs. This is a great thing.
Yeah, and it's not optional anymore, because if you want to accelerate your innovation velocity, the only option for you is to release frequent. So it's not even an option, right?
Agreed.
Got it. All right, let's. So thanks so much for the question there. I think another issue we want to touch on was kind of the impact of the macroeconomic situation. So I think we've talked about some of the technology shifts so far, the new architectures, the release cycle, but there's teams are also under pressure to control their spending. This is some interesting article that came out last week, talking about some of the pressures that cloud teams are under here. So 81% of IT teams directed to reduce or halt their cloud spending by the C-suite. Ilan, curious what you're seeing is the impact of the current economic climate on ops teams.
I think the relationships the ops teams have had with finance teams and the business has always been, can you do more with less? How can we be more efficient? So I don't think that's really changed. Anytime I was leading an operations teams or infrastructure team, one of my closest points of contact with the organization wouldn't just be the development teams that were pushing code out, but it was also our CFO and our VPs of finance and other folks like that really wanted to understand why we were spending and what we were spending on and how could we be better about it. So the current economic climate, if anything, is is just pushing us to do more of what we were already doing with looking for tools to take advantage, looking for paths to be more efficient in the technologies that we use. Can we scale things up and down based on demand, like Suresh was talking about earlier? Are there things that we can do to optimize our performance and how we adopt these services from cloud providers or from infrastructure providers? Whether that be contractual things that we can do, like, hey, I'm using a lot of this service. Can we talk about how we can make that more cost effective? Mm-hmm. Or why am I using a lot of this service? Why am I sending all of my traffic across availability zones? Let's approach that. Let's try to find cheaper ways to accomplish the same goals. And that's where, again, this is where the tooling and the data that we have now can really help us be much more efficient in our approach than what we've had in the past. Things are changing all the time. Traffic patterns are changing all the time. But if we have observability data that tells us, are we being efficient in our use of systems? That's great. We can make informed decisions about, do I need more servers or bigger servers, or will switching from x86 to ARM give me a bigger bang for my buck? Like all of these different knobs exist. And so I think the one thing that we're going to see as as we go through the next year or so of pain in the economy is people looking for more ways to be more efficient. And automation and data are going to be a huge part of making that successful. Turning off things that you're not using, like Sedai, could do for you, is a great path to being more efficient with your spend, so you can use it on the things that matter for your business. And observability is important there, because without measuring where you're being efficient and what your services are being used for, and if they're sitting there idle or if they're sitting there redlining, like how do you know? So you can't manage what you don't measure, and so those two go hand in hand together very well.
Yep, and just to perhaps reinforce the point a bit on the economy and cost, I think we have some data from a recent survey that we kind of ran here. We asked a set of AWS users what their number one challenge was. This was at the AWS Community Day event last month. So cost came out here as the top issue, followed by performance, and then ops productivity. Ilan, just to build on what you were just sharing with us, that people need to do more of what they were doing. What are you seeing as some of the key challenges kind of around sort of managing for cost or performance among your customers?
I think a lot of it is what I was saying earlier, which is how do you connect how do you collect all the data so that you're making efficient decisions? And there's a whole plethora of tools out there these days that are going to help you with Datadog and otherwise that are going to help you understand resource consumption, understand cloud consumption, understand third-party services that you're consuming from, and help you better understand where all of that spend is going. Because that's step number one: is you can't fix a problem if you don't see it, if you don't understand it, if you don't see where it's coming from. And then the second step is like, how can we make this not a human problem anymore? Mm-hmm. To what are there ways in which we can automate it? And that's there's are there ways that we can make this part of a systemic sort of regular process that we do? It's very easy for somebody with one API call to spend a lot of money with SaaS providers, with cloud providers, with everybody else. And so you can't just wait until the end of the quarter when your CFO or your finance guy or gal comes in and says, "Why did we spend this much money on our cloud provider over the last 3 months, 6 months?" And you're like, "Oh, I don't. Somebody forgot a compute cluster online that's been like idling for the last 6 months." That's too late. Like at that point, you're closing the barn door after the animals are already loose. So I think the most important thing right now is how do we get actionable insights into what our environment is doing and how we can be more, and where our spend is. And then are there ways that we can either automate it so that, the most common issues are fixed and easy issues are fixed quickly, or to bring it to the people that can make the most impact, which is the engineers that build and develop your software and that are making decisions about how they're deploying that software on a day-to-day basis. Bring it to their front of mind. Like cost is just as important as availability, as performance, as security. Like these are all parts of operating a business and a service well. And so, nobody wakes up in the morning and says, "I'm proud that I wasted a bunch of money on idle cloud resources," right? Like they want to be able to say, "I ran the fastest code that made the most money with the least amount of spend, with the least amount of compute time. Like, look how efficient I am." And they want to. In many cases, you'll even see teams at organizations competing over who's better at this or not. And so, but they can only do that if you've given them the data to say, what was their spend and how did it relate to what they got from it.
Yep, got it. So there's a couple of things I want to double click with you, Ilan. One around kind of Kubernetes and one kind of on serverless. So we've got another question here. On the Kubernetes side, Datadog's done some interesting resource here on the sort of the challenges of trying to manage for cost or utilization. If we can pull up one of the slides here that it talks about the Kubernetes kind of, I guess, underutilization problem. Ilan, we saw that Datadog kind of published this, which basically seemed to suggest that folks who are maybe having some challenges, sort of managing the kind of resources here on the Kubernetes side. What's your sort of take on this data?
Yeah, I think this kind of hits back to what we were talking about earlier, which we have a lot of the APIs and a lot of the tools and a lot of the capabilities in our platforms now to let us make adjustments to how we're using, how efficiently we're using our infrastructure, how efficiently we're spending. But organizations aren't consistently adopting it. They're like, to be clear, there are some that are doing this very well and they're operating very efficiently. But I think, as you can see from the data here, people overestimate what they need and don't always tune accordingly. And this is where hopefully we'll see. I'd like to see more adoption of platform components like auto scaling in the raw compute, or HPA and VPA at the Kubernetes level, or other approaches to really make sure that we're looking at how our environment is operating and then making sure that we're adjusting the usage based on that. Because humans are terrible about guessing at how many resources they need and when those resource spikes will happen. Computers can look at those trends and make very good decisions. And so the more we can push that into the platforms and take that out of people's hands, the better. This data is showing that the trend is going in that way. We're just not there in terms of efficiency yet.
Yeah. And Ilan, my thought there was, should we even ask humans to configure those thresholds, right? If you look at the threshold, it's 30%. Now, can I configure it to like 90%, and that would probably be it? But if I'm configuring it, I'm taking the responsibility of handling that load at the 90% beautifully. And I will have to look at 10 metrics. I'll be scared, right?
Yeah.
So
I think in an ideal world, we're not thinking about CPU and memory and IO and load and all these other things. Instead, we're thinking about what's, we try to find a metric that is more representative of what the customer experience is, or what the business of what business success is. Forget even customer experience. So maybe you're not working directly with customers. Maybe you're an internal process or a data, a batch processing system or whatever it might be. Like, what is the definition of good for you or bad for you? And so in the case of a web application, maybe it's reduced latency or reduced errors, or something that you can attribute directly to customer experience. In the case of a big data processing in the back end, maybe you actually want to be at 100% CPU all the time, because otherwise you're just wasting CPU on that compute cluster. But figuring out what is the measure of success? Is it how quickly did a job finish? Is it how quickly did an API call respond? And then how do we, ideally, I'd love to be able to say to the platform, optimize so that you're as close to, this many milliseconds on these response times as possible. And then you figure out, do I need more memory? Do I need more IO? Do I need more, do I need more CPU? And, that's where that automation hopefully kicks in. I don't, right now, Kubernetes can't know that what I care about is latency of API requests. It doesn't know my business. It knows how to serve, how to run my containers. It knows how to run my controllers. It knows how to run my software. But that's it. I have to tell it what I care about, and that's where HPA and auto scaling and all these other things that we have, whether it's in Kubernetes or out of Kubernetes, relies on us as humans to tell it what to scale on. CPU probably isn't the only thing you want to scale on. You want to figure out, is there something else that's that matters more to the business, matters more to your customer, and yeah, that's again, this is where as we move into the next phase of automation, we'll hopefully see more and more of this as the way we think about it, rather than, oh, my disk is full or my CPU usage is high.
Yeah. Yep. In fact, appending to that question, so let's say we configure, I'm just going to examples, right? So let's say we configure latency as 4 milliseconds. But that 4 millisecond is almost impossible with the current traffic and the current dependencies, but I'm configuring it. Now I'm telling that it's 4 milliseconds, and if there is a production issue, it's on me. So how can we help clean that up? How can we take that, because I'm helpless. That's all I know.
Yep.
And when in a good condition, this is the latency. I do not know when that bad condition, maybe it's when I'm sleeping. I don't even know when my dependencies go down, but I have put that 4 millisecond there, and that's now the cause of my production issue.
Yep.
Right?
Yep. Yeah. No, I think that's, have to have attainable goals, and have to be able, have to look at a mix of the different data sets. But yeah, you're right. Like, this is, this is where it's hard. And I don't know. I don't think we've reached we haven't reached level 3 self-driving cars yet, and we haven't reached level 3 self-driving infrastructure and applications yet. But
exactly.
But I think we're moving in that direction.
Yes. Okay.
All right. So we did have we sort of covered Kubernetes a little there. We did have a question on serverless from Mahesh again. I'll just interpret that. I think I guess probably the question for Ilan, you and Suresh here. I guess when it comes to serverless, kind of I guess some people might think the challenges of trying to manage here sort of go away. It's all taken care of for you, but maybe that's not quite the case from an ops perspective. Maybe you guys could give some thoughts on that question from a serverless perspective.
Sure. Did you want me to?
Yeah, if you want to take it first. Yeah, please.
I don't know I don't know if I see security as more of a concern for serverless than I see it for server-full workloads. Mm-hmm. Security is just a concern for everybody these days. As more and more of our businesses have moved online, there's bigger targets and bigger surface areas that can be targeted. So I don't see that. And in terms of operations, as we were saying at the start, there's still lots to. Serverless has taken away a lot of the things that you used to lose sleep over in the past. Like, is my disk full? Not my problem anymore. It's not my disk. Yeah. Are there too many requests coming in? Again, not my problem. In theory, Amazon solves all that compute problem, but there's still things to tweak there. Like how much concurrency do you allow on that function? How much memory are you provisioning for for those functions? Like it's not like operations has gone entirely away. We've just changed how much, we've changed the percentage of time we spend thinking about infrastructure problems, and we've changed the type of infrastructure problems that we think about. And this is just an evolution, right? Like operations, operations or infrastructure engineering or whatever you want to call it these days, DevOps, whatever. Like this is an evolution that we've had for the entire history of compute. I assure you, punch card operators were thinking about a very different style of operations than what we think about today. But there were still operations to be done. And you're like, oh, I don't have to worry about that anymore. I worry now about the network or the physical infrastructure, and now I worry about VMs or processes or functions or containers or whatever it might be. There's always something to tweak. There's always something to make better, and it's just a question of thinking about new approaches to new technologies. Like this is not systems admin jobs are not going away. They'll be here for the foreseeable future.
Yeah. Yeah, in fact, I 100%. I think it's just extending to that. So it's just getting more sophisticated in my mind. Initially, you used to write, as you said, right, on VMs, you used to adjust things, or you used to look at disk full. Now you are probably configuring your provision concurrency. You get to do a lot more sophisticated operations than before. Ilan, so if you look at the problems, I think we can probably divide it into three. One are challenges, right? One, rapid release cycles, meaning I cannot survive without innovating. That's not optional anymore. So I have to innovate if I were to be relevant. The second, I have to keep my cost still manageable, right? And the third aspect is, to do this, I have picked a set of complex architectures, like not so simple architecture, especially in terms of dependency. With these three, I still use my older style of management. I still ask people to go look at all your 1,000 dependencies and see who is running efficient, right?
Yep.
So how do people tackle this? What is your advice there?
Yep. I mean, I think they need to find. I mean, there's a lot of complexity, here with modern applications, and I think this is where we need more automation, more observability, more visibility into what those dependencies look like, and a lot of times as organizations move to these microservices architectures, as the organizations grow, they don't even necessarily know who the dependencies 3 layers down are. Without looking at their observability tooling, without looking at their service catalogs and other tools that help them understand those interactions. And so just we need tools to help cope with that. And those could be that's where I think where observability data and automation really fit in hand to help improve that experience.
Got it. And especially when it comes to, as you mentioned, right? So when it comes to tuning things, when it comes to availability issues that are interdependent, relying on automation/autonomous systems probably would help them focus on these higher order tasks, right? That they really enjoy doing. So if you ask a team to continuously look at things and make it efficient or make it better, I think chances of you having a team for more than a couple of years is fairly low. Right. People, it's boring for them. It's toil.
Yeah, nobody enjoys the operational toil, and then I guess that's where, as we've been talking about throughout the last 45 minutes or so, is like that's where that's what all these platforms and abstractions and these new technologies exist for. It's to take that toil away, and the more I think this is where automation. Automation, through those platform abstractions, through those APIs, is really important to us. It's where being able to plug that into the observability data that we have and other information that we have about how our environments are operating, so that we can connect the two and make smarter decisions, both in an automated and in a manual way, less painful. Like that's all critical to being to keeping your teams happy and to keeping your business running.
Exactly. So if you can pull up the slide of that example of automation, how to scale down or scale up with automation versus autonomous, that'll be awesome. The slide before this, if I'm not wrong. Yeah. So this is the heart of a scale down in production. Once you get approval, this is what typically you do, right? So you have to define a rule. Now you have to define a metric, and you have to define the action, right? So when you say scale up or out, vertical or horizontal, right? Now these three are the critical decisions, and these three have to be made by humans. If there is anything wrong, the question is not on the system, because the system is exactly doing what you're asking it to do.
Yeah.
So that's where that non-green color can be converted to just an autonomous system. The system looks at all metrics and says, these two are your health metrics, and these two are your lead metrics. And they say, look at the lead, figure out when that is happening, and find a buffer there. So now you provided yourself a buffer, a safe buffer to act on it. Second, you see what exactly is the threshold there. So if it may not be 30 at 11 o'clock daytime, it may be 30 at 11 o'clock midnight. Right? So that is the second part. The third part is really defining the action. Is it up or out? What exactly does your application respond to? Is it responding to a scale up or a scale out? Now, if these are made, then the rest of it is exactly the same, except for one key thing, which is learning after the operation. Once you scale up or out, make sure you're not wasting resources. You got what you expected to get, and get a reward for it and do a better action the next time. I think that's what I define an autonomous system as. It has to figure out what needs to be done. That decision making has to be taken from humans to that system. Humans should be out of harm's way. That's my definition of like how an autonomous system should really help. Right? The VPSP has a role to play here. They are the good automation that is really executing all of this. An autonomous system should probably handle that VP and HPA. That's my take on it.
Yeah. And for those who are sort of not familiar with this autonomous language and how it's different from automation, we also tried to make an analogy to cars. Elizabeth, we could pull up that one as well. So we were discussing with Ilan kind of before the call here, and Ilan was kind of mentioning earlier that you can think of it similar to like level 2 or level 3 in terms of the autonomous spectrum of vehicles. You could make some kind of parallel to, for example, how you would do scaling, as Suresh mentioned, in other cloud tasks you could sort of place on that spectrum as well.
Mm. Yep.
And Ilan, what are your kind of thoughts here on, I think you mentioned earlier that, it's sort of from the cloud side, we're kind of starting on the left and moving to the right here over time.
Yeah. I think this is, as I've said before, I don't think any of us is in fear of our jobs probably until we get to level 5 or level 6 automation here. So there's always more for us to do. Yeah. But yeah, I think right now we're squarely, most organizations are somewhere between, levels 1 and 2. We all want to get to level 3, but I don't know if the platforms are really there yet. And hopefully we're seeing that expand, over the next couple of years, and that's where, that's the dream of all the automation that we're building, is how do we get to the point where, you're not focused on infrastructure, you're focused on your business. Unless your business is infrastructure, in which case, like, I don't want Amazon to stop focusing on infrastructure. They should keep Amazon, Google, and Azure. They should get that right. But for me, like, I just want to write my code and know that it's operating performantly and efficiently in production. So,
right. I have a follow-up question there, Ilan. So how do these autonomous systems and automated systems coexist, like APMs and an autonomous system, right? If you look at an autonomous system, it is really taking all the data from APMs, all the data. It doesn't have any intelligence on getting the data. Everything comes from Datadog or something similar. We pull the data in, we do some analysis, we execute something, and we feed it back to Datadog. That's our integration with Datadog. So we are just a man in the middle right there, pulling data from Datadog, sending the output back to Datadog again.
Yep.
The users do not have to leave Datadog to get Sedai, for example, our
Yep.
platform, right? Is it how you see these systems that people build in-house also work, or is there another way to operate?
Well, I mean, I think the central pane of glass or single pane of glass has always been a dream that that has existed in our industry for for as long as we've been thinking about monitoring and availability and observability. And so putting the information that you care about all in one place, and including some of the actions like the things that you're talking about here for automation and approach, is really important to your success here. Because if you're not looking at it every day, you're not going to pay attention to it. And so hopefully, and you want to close loop there between that automation that you're building and things like Sedai and all of that data that you're collecting in that single place, which is Datadog. So that's that, or your other observability tool or whatever it might be. So that's critical. As far as building it yourself, like I don't know. I mean, our businesses are very complex as they are. We have only so many hours in the day to build the products that our customers care about and the things that actually make money for our organizations to pay our paychecks. I question whether or not that's the right. This is the same build versus buy discussion that you probably had on every aspect of everything you've built or bought over the last over the time of your organization. I would venture to bet that there's very few organizations that have the free time and free engineering bandwidth to go and build a completely, a complete systems automation tool like you're talking about with Sedai, or an observability tool to the level of something like Datadog, where they have all of these, all of these data sets, all of these visualization and analytics tools to help them understand the performance and the availability and the security of their environments. You can if you're an organization of a couple hundred people, how many engineers can you really put on those platform problems or those observability and automation problems? Yeah, I would much rather have my engineering teams focus on the things that I can change and tweak and be most impactful to my business, whether that's new features or integrations between my code and the platform, than I would on building a platform. Same reason I don't try to build my own container orchestrator from scratch. I'm going to pull Kubernetes off the shelf or ECS or one of the other platforms and use it, because I should be focusing on the things that matter most to my business, not on the things that are not my core competencies. And so that would be my take. But every organization has to think through their budgeting and their spend and of both human and financial capital in different ways. But I don't know. We all stopped racking and stacking servers a while back because Amazon's really good at it and Google's very good at it and Microsoft's very good at it. I'm not. I don't have the same supply chain that they do through all these different vendors. I don't have the same ability to infinitely expand my data centers that I'll every day, all the time. They do that for me. Great. So I focus on what's important to my customers and my business, and I hope that we can. I expect organizations are going to use the same approach for how they think about other abstractions in their environment, whether it's containers, whether it's automation, whether it's observability. Like, focus on the things that move the needle for your business.
Got it. Thanks.
Great. All right. We got a couple minutes left now. I'd like to see if we can get through some of the questions that the audience has asked. We've had a couple of questions from Eric Johnson, who's been watching on YouTube. Elizabeth, we could pull one of those up. Great. Yeah. So maybe Ilan's a question for you. I guess, how do you sort of incorporate kind of customer experience into the configuration? Like, I'm interpreting this as kind of how should you look at actual performance or how it's experienced by the customer and tweak the dials?
Well, so I mean, this is where I guess infrastructure configuration can mean a lot of things. So I'm going to focus on more on the resourcing side, like we've been talking about now, and less on less on all of the other different types of configs you can have here. But yeah, this is where, if you have an APM tool that can look at the user experience, whether it's latency on an API or a web page loading or whatever, or on a query returning from your database or something else like that, you can feed that back into the HPA, the HPA situation that we were talking about earlier, or your auto scaling solutions, or platform like Sedai and have that drive more, address how many resources, how much you're assigning what resources to which parts of your workload, and that's how you're connecting. That's how you're making this like a fully interconnected system, right? Which is your whatever tool you've got in place, whether it's Sedai or auto scaling groups or the Kubernetes capabilities or the other orchestration platforms. Are going to be querying data out of your observability platform and saying, is latency where I need it to be? Is resource usage where I need it to be? Yes, great. Leave things as is. No, well, let me tweak things up or let me tweak things down to achieve that goal. And I've seen folks have a lot of great experiences in connecting that data set full circle, so that their autonomous systems are making decisions based on those inputs from customer experience.
Yep. Makes sense. Okay, and I think we got another one from Eric as well, asking if serverless is more expensive. I think perhaps relative to containers.
I think this is all a question of right tool for the job, and you have to look at your workloads and what you need. I've seen. I've worked on teams. I mean, this is even when I worked on teams years ago, where like I needed to do. I remember a project once where we needed to do a bunch of image manipulation on the fly whenever somebody made a change in a CMS. Well, like serverless was serverless and on demand compute was amazing for that. It only did we only spent money on that compute when there was work to do. As there was work to do it, we took a process that we were spending many thousands of dollars on it. I think we were able to bring it down to $2 or $3 and do it a month and do it very quickly. Now, if you're doing something that doesn't lend itself to evented workloads or doesn't lend itself to the cost model of Lambda and Azure functions and Google functions, well then no, maybe it's more expensive to you. But you have to evaluate that on a case by case basis. I don't think there's a rule of thumb that like serverless is more expensive than server full. It just depends on how spiky is your workload, how evented is your workload, how much state do you need to keep, what types of resources do you need. All of these things fit together, and you also have to take that into account. How does that interact with the rest of your architecture and what you're doing? If you can save a bunch, if optimizing over on one side and moving to serverless, maybe saves you a small amount of money, but you still have to keep a whole bunch of other things over here running in order to solve it in a serverless environment. Maybe that's not the place where you want to focus. You might want to focus on your bigger opportunities for savings. So I don't know. Like every time somebody comes to me, even like you were saying at the start of the call, like is serverless go away? Is containers going to go away? No, none of these things are going away. It's all about having a toolbox full of useful tools that we can pick for the job. I won't try to hammer in a screw, and I'm not going to try to screw in a nail. I need the right tools for what I'm trying to solve, and this is where, Eric, I don't know what your environment looks like, but you have to make the right decision for you based on the economics of what you figured out with your cloud provider.
All right, got it. Okay, well, thanks, Eric, for both of those. We also, I think we're basically at time now. We did have one of the questions from Binu. I've just shared offline on LinkedIn some response back to her. So I'd like to wrap things up now. Really, thank you very much, Ilan, for joining us today. We really appreciate your insights, and hope to have you back again here soon. So thank you very much.
Thank you very much, Ilan.
Yeah, it was fun, and I'm excited that we were able to kick off the podcast series and hope to be back someday. So thanks, John. Thanks, Suresh.
Okay. Great. Okay, and thanks everybody for watching. Appreciate it. Bye for now.